Hello everyone. This video is about design and analysis of algorithms lab programs. So you all know about your curriculum of third year or second year. It depends upon the university, of course. So this is exclusively for lab programs. I wanted to explain you about what is the program according to the syllabus. I'm following with Usmania University syllabus of Hyderabad. So if it matches with your university syllabus, you can also go through with the explanation. So the style of explanation will be, or the pattern of the explanation will be, I'll take a program from the curriculum and I'll explain you what is the algorithm with the explanation how this algorithm will works. Okay, and the other video following with the same video will be having source code. So we'll get it start. The first program is about print all reachable nodes from a given starting node using BFS. So it is pure about graphs. We know about the traversing techniques of graphs that are BFS and DFS. So exclusively this program is what we have to print all reachable nodes from a given starting node. So from the question, we have to understand about how many total number of vertices we required. Fine. So I'll basically use Java for my explanation. The next video, as I mentioned just before, that I'll write a source code and I'll show you the execution process. So for the execution or else for the implementation, we'll go ahead with these steps. What is the first step? Question only saying you that you have to print the reachable nodes. That means you have to know how many number of vertices you are dealing with. And if when you are coming across with a number of nodes, then what is the adjacency matrix of the directed graph? Let's say that I have taken the total number of vertices or 3. That means for this total number of vertices, something like of 0, 1 and 2. These are what? 3 vertices. These 3 vertices are connected among each, right? That means 0 can be connected to 1, 0 can be connected to 3 and 3 can be connected to 2. So this is actually a graph, correct? So this graph is having some connection with the other vertex and it is not having connection with the other vertex that you can find over here. 0 to 1 you can find a path, whereas 1 to 2 it is not. When path is existed, we'll tell the direction that it is existed with 1. If you do not find any direction or edge, we'll treat it as 0. So with this connection establishment, we'll be getting with adjacency matrix. So what is adjacency matrix? Adjacency matrix basically consisting of zeros and ones, where 0 tells you there is no connection. 1 tells you the connection is existed in between the vertex. So you can also pronounce this one with cost adjacency matrix. So we'll just give you the cost. Okay, and so we come across with the number of vertices and the graph. Then from which vertex you are starting, that's also important. So these 3 are inputs to our program. Now the logic is all about mark all the vertices are not visited initially. Fine. So when it is not visited is equal to, we'll just write it is false. If you are taking a boolean data type, if you are taking an integer value, you will just write visited is equal to 0. That means it is an array of elements where it stores as long as you are visiting, the array will get updated. Fine. Now, so what I have to do? I have to retrieve the visited array with the visited vertex values. So initially how I have to deal with this? Now look at this explanation. Usually this is what we said about. So phi indicates you that these are number of vertex and this is what cost adjacency matrix for so-called this graph. So this graph is having connection from 0 to 2 and 0 to 1 and 1 to 3 2 to 3, 3 to 4. These are the only connections of this graph. Now, do I have reachability? Can I reach all the vertex? Yes. So that you can find in the graph, correct? Now, programmatically, how I have to understand through BFS. So BFS is what? Something level by level. It is first come, first serve. So that means I'll use a data structure where it accompany all the vertex, correct? So I have to go with level by level, as I said, correct? So now in this level by level, I have to find the first of all the starting vertex. Let's say that I am starting with this vertex. So I have to find the level of this one. The first level is what? 1 and 2. So that means when I am finding the starting vertex, I have to come to the next level to visit these two vertex. What is the data structure? What is the data structure used for this case? There are many data structures, as we know. What are the data structures? Arrays, list, stack, arrays, list, stack, queue, all these are there. So queue is the best suitable data structure. Now I'm just going ahead with the queue. Queue is the data structure to place the elements 2 at a time or 3 at a time, 4 at a time. It depends upon the vertex elements to which it is having connection. Let's say that I started with 0. Now, so 0 is inserted into the queue along with the adjacency of the vertex. That means 0, 1, 2 are in the queue. Now, 0 has to be removed out of it because it is visited. We visited this. What do you mean by visiting? Visiting is going to the vertex and exploring the vertex. Yes, I just repeat. Visiting is what? Graph is all about two functionalities. The two functionalities are visiting, exploring. Visiting is going to that, exploring is finding the adjacent. So I just went to the 0 and I found the adjacent of this. That means I completed visited. When I have visited, remove from the queue. When you done exploring that vertex, when exploration is completed, remove that from the queue. And where I have to keep that? So whichever is visited, that have to be moved to the visited array. Now 0 is here. That means we come across with the exploring the vertex. Now let's repeat the same process. Now after the 0, we'll just move to the 1. Now again finding what? Exploration. Exploration of 1. 1, that means what are the adjacent vertex to the 1? What are adjacent vertex to the 1? 3 is the adjacent one. That means it is connected to 3. Now let's put 3 here in the queue. Now finding exploration of one vertex is done. Then what I have to do? Remove. And whichever is you removed, that have to be placed in the array. Now 1 is removed. Next, what I have to do? The same process will be applied for 2. Now go to 2. What is go to 2? I'm visiting this. That means I'm exploring this vertex. What are the connections? Adjacent nodes of this 2. Find it. 2, 2, 3 was there. But 3 is already there in the queue. Correct? So there is no other vertex newly added into the queue from 2. So leave that. Now come to 3. Now you have to, before you visit 3, you have to be remove this one, no? Now remove that 2. Later. Now come to 3. When I can remove 3? After exploration is done. You have to explore the 3. What do you mean by exploration? Finding the adjacent nodes of that vertex, which is adjacent to that 4. Adjacent means finding the connection to which vertex it is connected. 4. 4 is not visited so far. So now 4 will be written here. That means 2 completed. Now you have to visit to 2. That you remove this one and you please put here. The next 3 exploration has done, no? 3 also can be removed. And 4, do you have any exploration of 4? Did you find any connections to 4? No, it is the last one. So no exploration will be done for 4 and 4 will be placed here. Once queue is empty, now look at the algorithm what I have done. Look at the 5th step. insert the start node into a queue and mark it is visited. That is what we were done. And we were repeated the same steps until queue becomes empty. So once after you done exploration for 4, you have to remove this 4. As we did not find any exploring vertex, you have to remove this 4. Now queue will become empty. So this process will stop once queue is empty. Then we will be printing all the nodes what are reachable from the starting vertex. That means we'll print this one. Fine. So this is what the algorithm. Have a look. It helps you to write into the examination. So it's definitely worthful to write into the exam the same way algorithm. If you are good in the programming, you can also write the coding part wherever it is required in the theoretical steps. Fine. Repeat until the queue becomes empty. We'll write a condition over here. You just have look into the second video, continuation video part 2. You'll understand that little bit pseudocode where you can include into these lines. Fine. If you write this also, it is okay. Evaluator can understand that you know little bit about how BFS works. So for examination point of view, when it is about algorithm with the explanation, it is okay to write in the exam. But I told you that I'm starting with the lab programs. So I'll explain you in the next video about program with the execution, explanation, coding part. Right? Thank you all.